Hello friends, welcome to my channel Code Destination. So as we are continuing this challenge one code one day, and we are taking the topic matrix. So today we will also discuss one question from LeetCode, and we will think how we can approach that problem, and we will think the intuition behind this. We will not directly solve the question just following the logic. We will first build the logic, then we will apply that logic, and we will solve the question. So for today we are taking the topic matrix. So in the matrix we are taking this problem number 48 from the LeetCode. It is rotate image. It is a medium level problem. So basically just in this problem we are given a n into n 2D matrix. This n, like row and column value is same, and we have to rotate the matrix in place. Basically we don't need to use any extra space here. So here this matrix is given. So suppose this is matrix in the example number 1. Suppose this matrix 1 2 3. In the first row the value is 1 2 3. So if you rotate this 9 by 90 degree, so it will come here. The first row value 1 2 3 will come in the last column 1 2 3 here, because we just rotate this like that, like 90 degree clockwise. So how we can think about this problem? So let me share my whiteboard first. Yeah, so for that I prepare already something so that I can explain in the less time. So we have given this yeah, so suppose, let me take, yeah, so we have given this matrix A matrix, and we need this B matrix. So I just build the relation between ith value and bth value. So we know, like, for representing any matrix value we are using ith, I and j variable, like I for row and j for like column. So suppose this is the size of m into n. So this m is 3 and n is 3. So what we can observe here, like for a00 is equal to b02, a10 is equal to b01. So as for all value I represent here, and after that if you analyze that, like suppose I take first example, and suppose for this 0, like this 0, if suppose I consider this 0 is row, like for this first example, if a00 is equal to b02, so I can take, like, for this value, like for this value you can see this 0 1 2, like I value is first is 0, then 1, then 2. And in the B matrix, this for this j value, whatever j value is here, because j is constant, in for this all I j is 0. So and in the B matrix, for all cases the I value is constant. So we can represent this j in term of I. So that's why this j value is constant here and I value is constant here, because whatever the I value is here which is constant, that should be represented as a jth index is here. And that I value in the A matrix, like I value is first is 0, then 1, then 2. And in the B matrix, for that I value, the j value is decreasing. So like in A matrix, this I value is equal to B matrix of this I value. Basically in the term of j we can represent, because j is constant. So basically it is whenever I is basically I is increasing, so j is decreasing. So that's why we can represent like that. So after that we can see, like, this formula is coming, because for every b I jth value, this in the term of a we can represent like that, a n minus j minus 1 and I. So just to be, when we will do some analysis in this example, we can represent, we can find this formula. Okay, I hope you understood. And in this formula what we can observe, like suppose we have any a I j. Suppose I convert this a I j in, like, in the, like in this form. So like we can get this bij, because at the end this is equal to bij, and bij is our result. So what we can do here, suppose we can see, like first we are I j value we are swapping ji. So what it is doing, basically we are doing I a I j, we are swapping the ith jth value with the ji, and in the term of matrix we call this transpose. So just it is just naming convention, like we are just following the name. It is called transpose. And after transpose, what we are doing here, we can see, like every j value is converting into the n minus 1 minus j, and every I value is converting into I. So suppose I take an example. So suppose a 0 0. So a0 is converting, we can see its size is 3 minus 1 2 2 and 2, so 2 0. And for let's suppose for 0 index, for 0th row, and every, suppose I taking the 0th row and first column, then it is coming, for 0th row it is 2 and 1. So for, suppose I am taking 0 2, so it is coming 2 and 0. So basically we can see, like, for basically it is swapping the column value, because either row is same. So basically, sorry, like for every what we can see, like for every 0th value, it is swapping with the 2 0 value. Like basically what it is doing, this value swap with this value, this value swap with this value. So basically it is doing like that. But on which matrix? After once we got the transpose, and on that transpose, like whatever result we get after the transpose, on that matrix we will apply this swap, and we can get this result. So same logic we will apply in the code, and let's see how we can write this logic in the code. So let me minimize it first. Yeah, so let me write it here. So what we can do first, yeah, so okay, suppose basically I have to loop row wise for every row. So suppose row is 0 and row till matrix dot length, which will give the total row, in this case 3, sorry, yeah, row plus plus. So we will iterate row wise. Okay, so first what we have to do, first we have to transpose, we have to get the transpose, because as logic mentioned here, first we have to get the transpose, and on that transpose we have to apply the logic. So, and we have to do everything in place, so that's why we will do everything in the matrix. So how we can get transpose, we can iterate like that. Column, first we will iterate in the matrix. So matrix 0 length. Okay, so for every row and for every column, what is happening for getting transpose, we are swapping ith jth value. So I will took the value of row and column first, because we have to swap it. Then I will swap this. This is just simple swap logic. So I will swap this row column with the matrix of column and row, because ij swap with ji. So whatever thing I explained, just for not any confusion, this ij is, I just use row column variable here, and this is ij, so just I use row column. So every row is swap with column, because ij is swap with ji. So I am just getting a transpose here, and at the end in the column and row I want the temporary data, because in t variable I store the row column value. So in this way I can get the transpose of matrix. So it will, at the end our matrix will like just swap the value, and it will convert in the transpose manner. After transpose, what we have to do, we have to basically, like as I discuss here, once we got the transpose, suppose this is the transpose matrix, so I have to swap every jth, like every jth value with the, like n minus 1 minus j, because first column value with the last column. In this way we have to swap every value. So same manner I will go loop in the loop row wise. So from the first row we will start matrix dot length and row plus plus. Okay, so we will do like that, and we will take two variable, call a column start, which is start from 0, and for that particular row column end will be that column value. So how we can get for any, like for first row I will get the length, which is the total length of like array, and it is 0 based indexing, so I will use -1, and I will swap. Basically I will write swap logic. So till when it is and like column start less than column end, and what we have to do, basically I have to do swap. So matrix of row, because we are doing row wise, so row is constant here, and call start will swap with matrix. I think, yeah, row will be constant, call and on the call end, like the last column. Okay, no, I think I stored this one, so I have to use that. Okay, call start will swap is matrix, row is common, call end. So basically this call end will swap with a call start. So here at the end, matrix row and call end, I will put the dummy which I stored already. So in this way we will, for every row we will swap the column values. So yeah, I think it should work, because first what I did, I just find the transpose, and on that transpose, like because we are doing in place, so in the matrix itself will convert in the transpose of matrix, and the transpose I just swap every column value. For every row it will swap the column value. How it is working actually, let me show you. So let me show here. So suppose, okay, what is, yeah, so what is happening, suppose I have many value like 0 1 2 3 4 6. Okay, so what it is doing, for 0th row it is swapping this value, then my row sorry, that call start and call and reduce, then it will swap this value with this value, then again it will swap this value, this value. So for every row we are doing this. Okay, so this will do, I think it will work. Let me run it. Okay, so there's something wrong, let me think why. Okay, I have to use here int. Okay, I think I didn't reduce that call start. So for one swap I have to reduce the next call start, next call end. Okay, otherwise this while will go in the like infinite loop. Yeah, so it is giving the wrong. Why? Let me think. We are just swapping ijth value here, like every row value is j value. Okay, yeah, I think it is doing mistake, because we can't find the transfer like that. Why? Okay, let me explain you. Let me clean all this thing. Yeah, so what is happening here, let me take quickly an example, like 1 2 3 4 5 6 7 8 9. So what is happening here, suppose if I write to loop for like changing any ith value j. So in the first iteration for 0th row, what is happening, this is going like that, 0 2 1 2 3 is going here. Okay, and 4 7 going here, 5 6 is going here, and 8 9 is going here. So what is happening in the second iteration, if it is swapping for first row, so here it is swapping this, like basically what we are doing for this first row, we want this first row here in the first column, we want this second row in the second column. Okay, so we want this type of behavior. But what is happening here, once we swap this first row here, so if we are going in the second row, so we are just getting the wrong value, because this 2 is coming, but we need this 4. So what, we can't do like that. So how we can like basically change the indices, we can do like that. Let me write again, 4 5 6 7 8 9. So instead of do like that, what we will do, we will just swap the this index value, like this index to this here, because it will also fulfill our requirement. Like this value should go here and this value go here. in this way, this value go here and this value will go here. So basically for this for this diagonal we will swap the just diagonal, like whatever data is up from the diagonal and down from the diagonal. So it will also return the correct transpose of data, because this is always same for any transpose. This row this diagonal value, only the up value and down value will swap to each other. Like here 4 will come, 7 will come. In this way we will get our correct transpose value, and here 9 and 6, and it is our correct data. But in that way we are getting the wrong. So what we have to do here, we will start our column not from 0. We will start from for every row, like for 0 row we will, like for this row we will start here that column value. For this row for this row we will start from here, from here, fifth value. So in this way we will swap only the correct value, and we will not lose our previous value. So let me run it. I think it should work now because everything is fine looking. Yeah, so our both the cases pass. Let me submit it. Yeah, so it's submitted. It is taking 0 millisecond and beats 100% of user with Java. So I think it is a great solution. So let me discuss the time complexity. So the first, like here we are looping, this is taking an iteration, suppose row. So n and m value, like row and column value is same. So it's suppose I taking an iteration it is, and this column is also taking an iteration. So total it is taking n square iteration. So this time complexity will be big O of n square. Okay. And the second loop, the same thing. Yeah, row is looping, and for every row we are swapping the value. So it is, in the worst case, it is also taking big O of n square. So it is total, like if I calculate, then it will come big O of I think, yeah, 2 into n square, and we can write this big O of n square. So this is a big O of n square solution, and we are not using any extra space because it is staying in place, and we are doing everything in the matrix itself which is given. So there are no matrix, so it is space complexity will be big O of 1. So this is big O of n square and big O of 1 space complexity solution. So I hope you like the intuition, whatever logic we write here, and how we approach the problem, how we can first build the logic for solving the question, and how we can write the code. So if you like my video, please like and share, and also subscribe my channel, so that in future if I upload any video you can get, and you can just try to understand the problem and intuition in proper manner. Yeah, thank you for watching my video.